So, my dear friends, we are opening a new topic today. Differential protection of transmission lines, or otherwise, the other name is carrier current protection of transmission lines. So, we have talked about protection of transmission lines using overcurrent and earth fault relays. It had many limitations. Distance relays also have limitations, and therefore, the best protection, but although costliest protection, is the differential protection of transmission line or line differential protection. So we enter into a new topic today. So we start a new series. Actually, the most stable, not only for line, for transformer, for motor, for generator, for anything, the most selective, reliable, and fast, most selective. That means only the faulty part will be immediately isolated, very reliable, and very fast, instantaneous operation. Such a scheme is a unit protection or a differential protection. The differential protection scheme compares the local current with the current at the far end of the transmission line. That means two currents are compared. And therefore, you see, the zone is the between the two cities, whatever is the portion, is the zone of protection. Therefore, if the fault is just 100 meter inside, say from the far end city, if the fault is 100 meter inside the zone, then it is sensed, and 100 meter outside the zones or 50 meter outside the zone is not sensed. It is so accurate. You see, no non-unit scheme, that is overcurrent earth fault or distance scheme, are this accurate. I mean, 10% inaccuracy is there. Here there is no inaccuracy. Very accurate scheme. So, if we go further, what actually happens in differential protection, that the current at the far end, when the fault is in zone, the current at the far end reverses for CT, because you see it is an interconnected system. Therefore, current reverses. This reversal of current makes the system very accurate. If the current is beyond the CT, then there is no reversal. That is the beauty of the scheme. The complete line section can be protected instantaneously, not the part of it, in case of differential. Yet distance relays are widely used because of many reasons. One is economic considerations. Yes, line differential is very costly. Another is, in differential scheme there is no backup. That is a big disadvantage. Therefore, distance has that advantage. Right? And also, as we will see, the mostly what people use is not simple differential, only differential, but people use carrier aided distance schemes. So distance is yet applicable. So that one has to remember. What are the limitations of the distance protection scheme? One is there are problems of underreach and overreach. You see, when because of asymmetry of current, there is overreach. Because of series capacitor, there is overreach. Because of teed line, there is underreach. Because of fault resistance, there is underreach. So, perfect reach is not there in distance scheme. And it is not possible to distinguish between a fault at the far end of the line It is within zone. It is within zone. Distance relay should trip. And just at the start of the adjoining line, these two faults cannot be discriminated unless you add a time delay. So time delay has to be added. So once again, then it does not remain to be instantaneous. So full section can never be protected instantaneously. That is the another disadvantage. But the worst disadvantage, my dear friends, is the if you consider a line section AB, I'll show you the figure. And large bulk of power is flowing through this line, some 300 megawatts say. So in such a case, our problem is this, that if there is a fault in the line, you have to clear, because fault is going to make the system unstable. Not only that, it is going to damage the equipment, that many disadvantages are there. Voltage drop will be there. But the worst disadvantage is the system will become unstable. But when you clear the fault, then also system will become unstable, because 300 megawatt is lost. So you are in trouble. To clear the fault is also disadvantageous, and not to clear the fault is also disadvantageous. But the fact that 85% of the faults, and mostly faults are LG faults, 85% faults are LG faults, and out of this 85% are transient. Therefore, if you reclose within 300 milliseconds, because you see 300 milliseconds is flash over time, 300 milliseconds you cannot reclose manually. So there are recloser relays, they will reclose. And if you reclose the rail immediately, and within that time the fault is gone, because the arc is extinguished. Therefore, the system remains stable. You have cleared also and you have reclosed also. See, so the use of auto reclosing circuit breakers is very advantageous in interconnected system having very large fault, having a very large fault power. Right? So in this case, distance relays are just useless. They cannot be used. That is what we would like to see. So we'll see the figure. Say R1 and R2 are the relays. If they are distance relays, then R1 will reach up to 80% of line section AB, and R2 will reach up to 80% of line section BA. So if you see, middle 60% is protected instantaneously by both. So if the fault occurs within middle 60%, then all right. The circuit breaker 1 and 2 will trip and then obviously reclose simultaneously. But if they do not simultaneously reclose, one will trip but 2 is yet closed, then fault will come from there. And when 2 trips, 1 is closed, so fault power will come from there. So system stability is yet in danger. So my requirement is simultaneous tripping and simultaneous reclosure of 1 and 2. That is just not possible in distance protection, because fault can occur in initiating 20% and final 20%. So if that occurs, then the tripping and reclosing are not simultaneous. This figure will clarify breaker 1 and breaker 2. This tripping, see, at circuit breaker is shown on, then it trips because fault has occurred, relays have sensed, it trips and it comes to off status. It remains off for 0.3 seconds, because I told you, most of the time there are calculations, there is a formula, but for 220 kV line generally it is 300 milliseconds. So within 0.3 second, it will reclose. The other breaker also should trip and reclose at the same time. Therefore, both the breakers should be open for same time and both the breakers should be closed for same time. Otherwise, there will be fault power fed from either end and system will become unstable. They will reclose. If the fault is sustained, it has not yet died down automatically, it has not self-healed, then it will wait for some time. It will trip again because the fault is there. It will wait for another time t dash, which can be 0.3 second or some another time which you reset. Setting is it in your hands. And then it will close again. But then if the fault is there, then it will lock open, right? Then it will not close. This is known as two-shot breaker. The statistics says that after first shot, the probability of fault having gone, fault having self-healed, is some 93% or so. And after second shot, it is hardly 6% or 5% or so. After third shot, if at all you go, then it is hardly 1% or so. And people have compared up to 9 shots because nowadays the numerical relays are giving that we are giving circuit breakers. I mean, we are giving facilities for circuit breakers to go for 9 shots. Then in 9 shot, it would be not some percentage. So I mean, 2-shot circuit breaker is more than enough, so to say. I mean, this is more than enough. But this should be simultaneous. And this simultaneous is only possible in line differential. That is the main thing to be remembered. So if you think of differential protection scheme, then one differential protection scheme is wire pilot differential scheme. That means physical wires are laid between the two ends. If it's a 100-kilometer long line, then 100-kilometer long wires are laid. See, try to understand that when we will talk of carrier, it is not so that because these 100-kilometer long wires are costly, 100 kilometers wires are not at all costly. Carrier is much costlier. But why we are using carrier, that we'll discuss afterwards. But right now, let us see what wire pilot differential protection is. Wire pilot differential protection is not used all the way. If at all it is used, then it is used for some 10-kilometer long line, very short lines. But usually people do not use wire pilot schemes. But for the sake of studying, because for the sake of starting, we will study wire pilot scheme. So in wire pilot scheme, there are two types of schemes. One is circulating current type wire pilot and another is opposed voltage type wire pilot. In circulating current type wire pilot, what is the concept? The concept is this. Circulating current type wire pilot, the concept is this. At both the ends, there are CTs at both the ends of the line. So you have to understand that this is 100-kilometer long pilot wires, right? And you are connecting in circulating current type wiring, and you have to lay the pilot wires. If there is a fault at F1 or there is no fault, normal current, then the primary currents I1 and I2 are same. Therefore, secondary currents I1 and I2 are same. So I1 minus I2 that is flowing through relay is 0. And therefore, relay does not operate. For fault F1 also, we are rather assuming that both the CTs are very accurate and they are matching at even fault currents, at even 10 times, 15 times the current. There is no mismatch in their saturation characteristic. That is an assumption. that is not true as such, right? And therefore, the actions have to be taken. Something like series stabilizing resistance or so. But let us not discuss because this is not much used. But under external fault condition, it is not tripping. When the fault is at F2, I2 will reverse, as we have told, no? I2, primary I2 will reverse. So secondary I2 will also reverse. And therefore the current passing through relay will be I1 plus I2 as such. Very high current. And therefore relay will operate. And it will give a tripping signal to both the breakers. It will give tripping signal to both the breakers simultaneously. So they will simultaneously trip and simultaneously reclose. Our purpose is served, but you can see that it has got many disadvantages. It has got many disadvantages. Wires are required to be of generous cross section. Say it is 100 by 5 ampere CT or 1000 by 5 ampere CT, then wire should be able to carry 5 ampere and then it should not develop resistance. Resistance should be negligible. Therefore, there should be thick wires. So that increases the cost. And because it is 100-kilometer long line, there will be large voltage drop because some resistance will be there. Not only resistance, because it is AC, there will be inductance also. So impedance drop will be there. Right? So when it comes to relay, probably the operating juice is not available and relay may not operate. So that is a great difficulty. Because it is not a transformer that the two CTs are just 10 meter, 20 meter, 30 meter apart, or a generator or a motor. It is a line. That is the problem. For a three-phase line, again, you have seen, see, in this figure, you are seeing two wires, but there are no two wires. This is a single phase diagram. So three-phase scheme, you will have to run 6 pilot wires. How 6 pilot wires? 3 for 3 lines, 1 neutral, and 2 for DC. DC because tripping is given by the relay and relay is at the middle and it is giving tripping at the ends. So battery is at the end and relay is at the middle. And once again, to keep a relay at the middle itself is very difficult. How can you keep a relay exactly at the middle? Exactly at the middle, there may be a river, there may be a road, you don't know, right? So to keep it exactly at the middle is, and CT saturation problems. Oh my lord, CT saturation problems are highly pronounced because you see, to think that both the CTs are having exactly a similar saturation characteristic is not possible. No CT manufacturer can manufacture like this, and there will be some difference when fault, external fault occurs. And then the relay may maloperate for external fault. That is the problem. Charging current in pilot wires. You see, there will be charging current because this is AC. So there will be charging current. So that charging current leakage is a problem. Is a big problem. So because of these problems, people thought of another kind of scheme, that is wire pilot differential scheme, which is opposed voltage type wire pilot scheme. In opposed voltage type wire pilot scheme, what do we do is opposed voltage type of wire pilot scheme, we do like this. That means we just make a cross. So certain problems are solved. First problem which is solved is I1 and I2 are same when external fault has occurred or no fault. So I1, if you just see, I1 and I2 are crossing. Therefore, the current passing through pilots is 0. So no generous cross section is required. Voltage drop problems are not there, which were there in circulating current type. You are not to keep the relay at the center. You keep two relays, R1 and R2 at both the ends. Because already there are many relays at both the ends. So keeping a relay at the center is not a problem. Right. So now if external fault occurs, I1 and I2 are crossing, so yet it is 0. So current flowing through R1 and R2 is 0. But if internal fault occurs, I2 will reverse. Current I1 plus I2 will pass. R1 and R2 both will operate simultaneously. R1 will give tripping juice to its breaker and R2 will give to the fast and the far end breaker. So the local end breaker and far end breaker will trip simultaneously and reclose simultaneously. So many problems we have solved of circulating current type. There is no need to install a relay at the middle. That is, a current flowing through air pilot is 0. No problem of resistive inductive drops. For three-phase scheme, now you require only 4 pilots because that 2 DC pilots are not required. Right? And actually, in circulating current or opposed voltage type of scheme, if you rectify the juice, then you need only 2 wire pilots. 2 wires are required. So rectification will need only 2 wires in opposed voltage type scheme. There you would require 4. Here you would require only 2. So that way many problems are solved. But certain problems are added. And that is a severe problem. What is a severe problem? That current through CT is under normal operation and under external fault is 0. That means the CT secondary is open circuited and therefore very large voltage is induced on secondary. CT secondary insulation will be damaged. Not only that, but the person touching a panel may get a fatal shock. Therefore, a very special CT, which are known as air core CTs or linear couplers are required. Simple CTs cannot be used. Therefore, CTs to be used in this type of scheme are very costly. Are very costly. That is the problem. So these types of schemes are not used. This is just for the purpose of explanation, right? That this way, this is the basis of differential protection. But in carrier current, we are going to use the same base. But we will not run wires. Physical wires we will not run. That is the only thing. Base is the same. Right? So with that, we end this about carrier. We will talk in the next presentation because we do not want to lengthen the presentation here for half an hour. Learn so much. Next half an hour at your leisure, you hear another further theory of line differential so that you are also not tired and you learn, right? So we read a sentence and complete the tutorial. Happiness is being satisfied with what you have. Whatever you have is enough. You deserve that much and be happy with that. Success comes from dissatisfaction. Those who find success, they want more and more. They are not satisfied with what they have. So whether you want happiness or you want success, that is your choice. Some person, novel, that means a philosopher, novel has said this sentence. Very good sentence. Happiness and success. Whatever you have, you are happy or you want more. You want what others have. Then success will be there. But with success, dissatisfaction will come. So with that, I remember Adapt Me. You also please share this video. We are in line differential. There are 3 tutorials in this series. And then we are going to talk of generator. It will be about 8 or 10 tutorials for generator protection. Then transformer protection. Then induction motor protection. Then bus zone protection. Then 1 or 2 tutorials on testing of relays. And because testing of relays we have talked about in practical also, so we won't talk more. But then we'll talk about the processor architecture, numerical relay architecture we'll be talking about. And then we'll talk about CTs and PTs, protective CTs and PTs, because that is very important. They are giving the juice to the relay and they're very important. Then we'll talk about circuit breakers, including the testing of circuit breakers, short circuit testing of circuit breakers. And then we will touch the over voltage protection. I think it will be 100, 120 or 140 videos covering 60 to 70 hours of protection learning. I hope you will love learning protection like this. Right now at no cost. But if you want to learn the mathematical part, the analytical part, if you want to answer the questions and to know how much you have understood, then you will have to buy the modules which will come one by one. Right now, 3 modules are there on Adapt Me. They are uploaded on Adapt Me. Fourth, the module on distance protection will be soon uploaded. So you have to buy the modules to learn fully. But this much theory you can learn free of cost. So kindly circulate this much of message. Thank you and good day.